This puzzle is called Summing the Mercury by DJV. I got it from the Discord Puzzle Archive on the CTC Community Discord. It should be about 3 out of 5 difficulty. That's what the consensus is, I guess, from people who've completed it. But it should also be a very good puzzle. So, yeah, let's take a look. I'll put a link to the puzzle down in the description if you want to solve it yourself. Let's look at the rules. So, thermometers. Digits increase as you go along away from the bulb. So if we discovered this was a 4, this would have to be, I don't know why it's saying 4 is wrong here. I don't know, but it's saying 4 is wrong. This would be a 1, 2, or 3. This would have to be more than 1, 2, or 3, so it'd have to be in like 5 through 9. That's pretty easy. So clues outside the grid indicate the sum of the digits along the indicated diagonal, so that's called, what is that called? That's called Little Killer. So let's look at this one. Here's 21, so these green cells have to add up to 21. And digits can repeat along the line as long as they're not in the same box. So like this could be a 9 and this could be a 9, for example. Yeah, so let's get started. Yeah, as I said, the link will be in the description. So this 8 clue is going to be very restricted because it's also on a thermo. So this is the smaller digit. But of course this can't be a 1 or a 2, so this must be 3, 5. It can't be a 1 or 2 because of the thermometer. The minimum this cell could be is a 3 because it's the third cell along, and that's what it is, so that's how that's going to be arranged. This 13 clue also seems very long. Let's look at this. So this is 5, so this has to add to 8. That's going to be the minimums here. So the smallest these two can be is 1 and 2. This is 1, and this can be 1 and 2. So what is this? I think that's right. This is 6, 7, 8, 9, 10, 13. Yeah, so this is that arrangement. We don't know which way around the 1s and 2s are, but yeah. So that feeds into this 9 clue, which must be 7 or 8, and actually must be 7. An 8 would put a 9. If this was 8, this would be 9, and then we would have I don't know, a 0, a 10, something like that on the end, which doesn't work. So this must be 2, 7. And this must be 8, 9 to finish off the thermometer. Let's see. We can look right here at the 10 clue. So this is the smaller of the digits. This is the larger of the digits. This can't be 8 or 9. So this can't be 1 or 2. And this 7 looks up and rules out the 7. This must be like this. This is 7, 8, 8, 9. But of course these digits are looking up, so this is just going to be like that. Okay, I am kind of worried because this is obviously going very smoothly. I'm getting a lot of digits, but this is supposedly a 3 out of 5 difficulty. So I'm thinking we're going to grind to a halt here in a minute. But yeah, let's savor this while we can. This 2 looks over here, which makes this 1, 5. So this is, what, 6, 7, 8? Yeah, like this, but this can't be a 9, so this can't be an 8. Okay, let's look at this long diagonal. Highlight that, so we have 24, 29 so far. What are the maximums along here? This could be 9, this could be 8. And let's add this up. So this is, oops, we have 4 9s, that's 36, 41, 49, 49 plus 15 is too much. So it's not going to be just straight maximums. 49 plus 15 is 64. So there's a little bit of leeway here. I don't see right away how we can lower that, but let's look at this one. We'll make it hot pink, 47. And let's just look at maximums again because I don't know. We're at 22 already, so this has to add up to 25. And this is at most a 2. So that's going to be very restricted. It would be even more restricted, obviously, if it was all in the same box, but we can actually repeat 9s all the way along here, can't we? Okay, that's a little unfair. Okay, let's look. Let me do 1 second. Yeah, if these were these all three could be 9s, and I don't see how they would like rule each other out. Right? Yeah. Oh, here's something. This is a 7 just by Sudoku. Looking into the middle box, and we can pencil mark 8s up there. 5s. Oh, 5, 5 puts a 5 there. That seems like it's going to be helpful, maybe. What 1s do we not have yet? So 1s are over here. Yeah, of course, 1s are along there somewhere. 1 is over here somewhere. And 9s are also over there. Okay, let's look at this diagonal. No, that's not this. Let's look at this diagonal. We already did the 13. There's actually a lot of... Most of these diagonals are going this way, going like negative diagonals. Let's make this blue, I guess. And this will be dark blue. Should just try to switch up the colors. Have we colored all of them? This is done. This is done. This is colored. This is done. This is colored. This is colored. This is done. This is done. This is colored. This is colored. Okay. So we've highlighted all of them. So hopefully that'll be good. So maybe the greens do need to be somewhat maximized. Not fully. If I remember correctly, this is... What is this? 29? Yeah, 29. Which would be 33 for these cells. Which isn't the maximums, but it's pretty close. Maximum would be 35. So what did I say, 33? 33 is minus 2, so this could be 789, 789. This actually can't be a 7. 6, 7, 8, 9, 6, 7. So this can't be an 8. This can't be a 7. I think that's correct. Okay, yeah, because if this is a 7, then this would be 9, 9, 8. And I guess it's telling me, yeah, I was gonna say that count must be correct because it's not telling me that the diagonal's wrong. Okay, let's look at this one. I think, didn't I just look at this one? 47. I'm at 22 right now, so this is 25. Yeah, which would imply fairly large digits, but because they can repeat, it's not as helpful. Let's look at this one. So wow, that's a lot. That adds up to 30, that adds up to 26. Actually, what is the maximum this digit can even be? What are the options for this digit even? Can't be 1, could be 2, can't be 3, 4, could be 5, 6, 7, 8, 9. So this is only a 2 or a 5. That seems like that's going to be helpful. I apologize if you can hear my chair. I've said this before, but it's a very, very squeaky chair. I try to sit still, but sitting still for like, well, I mean, it's only been 10 minutes so far, but what could easily be like, half an hour video is hard to do when you're also moving your hands and doing stuff and thinking about the puzzle rather than thinking about not moving. So anyway, long story short, I apologize if it's super loud. Well, I guess the super easy digits couldn't last forever, as I was worried about. Whenever I get stuck, I always look over to the rules because one thing that can happen a lot is if there's some rule that you just don't remember, especially like a negative constraint, like, oh, adjacent digits can't be next to each other or something. Like, well, that can easily break open a puzzle, but if you just forget it's a rule, then it's not gonna help. So I glance over there quite a bit. I feel like the 21 cage, since we have zero information about it, it's not going to be useful for a while. The dark blue, this adds to 31, which isn't that restricted. Let's look at the 35 again. So this is 35 minus 5 minus 4 is 26. That's actually very restricted, isn't it? I say that because we already have 13 here. So this is, what did I say, 26. Minus 6 is 20, minus 7 is 13. Minus 1 is 12, minus 6 is 6. So this is at most a 4. And it can't be a 1 or a 2. Is that right? Whoops. Let me open up a calculator here because I'm pretty good with mental math a lot of the time, but I don't want to, start doing a bunch of logic based off of adding a bunch of digits together, and, a silly off by 1 error would be. Did I get an off by 1 error? I feel like I did, unless I typed this in wrong. 5 plus 4 is 9, so it's 26, 20, 13, 12, 6. What am I doing wrong? 30, 24, 17, 16, 10, 6. So these two have to add up to 6 minimum, so this can't be a 5. But what am I typing in wrong? 3 plus 2 plus 4. Oh, that's what I typed in wrong. I typed in, yeah. Yeah, the absolute minimums along this line are 34. So that means we have 1 digit of leeway, which means this can't be a 9, which means this can't be a 5. So this is a 2. Yeah, I did the math in my head correctly, then typed it into the calculator. I typed it in correctly, but I guess depending on the word definition of correctly, I misunderstood what I typed into the calculator, which ended up confusing me even more. I typed in the minimums all the way across rather than taking into account that this has to add up to 6 if we're doing the rest of the minimums. Anyway, it's worked out. So this is restricted. So this is 6 or 7. So let's add up the maximums along this. 5 plus 9, 14 plus 9 is 23, plus 7 is 30, plus 9 is 39, plus 9 is 48, plus 8 is 56, plus 7, I'm gonna say 56 is 63, is that right? Yeah, so there's 1 digit of leeway now. So, off of maximum. So this can't be 6, this can't be 7. Okay, so we're working our way down. So if this is 8, this must be 7. Yeah, because there's literally 1 digit of leeway. And this is 1 digit of leeway off of maximums. Sorry, off of minimums. Okay. Oh, so if this is 7, this puzzle's broken. Because if this is 7, that's the 1 digit of leeway we have. But then this would force another digit of, like another non-minimum digit. So this must be 6. That's helpful. That's definitely helpful. 1 digit of leeway here. So this wants to be the 6 for the pink line, and it wants to be the 7 for the light green line. So let's look at this dark pink line, because I feel like these 1-2s are gonna cause some problems in a good way. Like, if we minimize one way, then it'll force the 1-2s to be broken. At least that's my hope. So we're at 22 here. So this is 25. Let's look at just what this can possibly be. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, there's actually a lot of options there. Maybe there's some regular Sudoku to do that could reduce some options. Oh, yeah, here we go. So where can 6 go in this column? It can't go here or here because of the 6. It obviously can't go there because of the other digits. And this 6 rules out there, so that's a 6. That doesn't immediately help, but always good to get a digit in. This has a 2 and an 8. No, it doesn't have an 8. It has just a 2 over here. Never mind. What am I doing? 8 is over here. I just had a massive brain fart. For some reason, I was like, yeah, I thought that 8 had to be over here. 6 is in the middle. 4 is over here. Oh, that's something too. Yeah, now, where's 4 go in box 6? It must be along the side in row 9. So no, none of these can be 4, so this must be 4. So all that's left is 3, 5 along here. There's a 5 right here. So this is 8, 1, and 9. Not immediately helpful. I was thinking, like, yeah, there's a lot of 8s and 9s, but it unfortunately doesn't have any direct impact on green over here. What's down here is 3, 5, and 9 as well. This can't be a 5, but everything else works out. Let's remove that for the moment. I don't like pencil marking 3 cells like that. I just don't think it's very helpful. Although, look back to here in about 5 minutes when I don't realize that 4 is as restricted as it is. And unfortunately, none of our work helped here. Oh no. So 3 must be in one of those digits, or sorry, 3 must be in one of those cells, which puts a 3 down here. Doesn't help. 6, oh, that helps. 6 must be up here in one of those 2 digits. What can this cell be? It can't be 1, 2, 3. It could be 4. Can't be 5, 6. Could be 7, 8, or that was looking promising until I got to the high digits. Okay, let's look at this line again. So we're at 22. So these 4 digits must be 25. So that'll be 23 if we take it to 23 minus 9. 23 minus 9 is 14. So then these have to add up to a maximum of 14. Let's do minimums, because I feel like this is going to reduce this a lot. So this is 22, so this is 25, minus 9. No, wait, I think I was on the right track the first time. If we maximize these 2 cells, then we minimize these 2 cells, right? If we maximize this, then we minimize this, right? These add up to 25. We subtract off 11, that's 14. These add up to a minimum of 14, which makes this like this, and this has to be a minimum of 5, 6, 7, 8, or 9. It can't be a 6, can't be an 8. Is it possible that this is a 9? 8 plus 8 plus 1 is 17, plus 9 would be 26, but these have to add up to 25. So that is like that. It can't be a 9, I mean. Okay, so we have an 8-9 pair, which forces this to be 7, which unfortunately doesn't help because that's still minimized. Again, we need to minimize light pink, maximize light green, and somewhere in the middle, hot pink. It's a hot pink, dark pink. Um, let's go through this math again. So this is 22. This is 25. If this is a 5, everything else is maximized. Which puts a 2 here and a 1 here. What happens if we put a 1 here? This has to be 2, which then minimizes this, which then maximizes this. It seemed nice, but I don't think that actually matters. It seemed like something that could do something, but it didn't turn out to be helpful. We have this... Oh, I already said that because we got rid of the 8 there. No, 7 must be up here somewhere. Whoops, one of these is a 5. So these are, at least 2 of these are 9, because light green needs to be maximized. There's 1 digit of wiggle room. So light green must be maximized. Sorry, so the selected cells, at least 2 of them must be 9. If this is 9, then this is 8. How does that... And then this would have to be a 7? Because the only way this could be a 5 is if this is a 9. So if this is a 9, 8, 7, this has to add to 10 then? Yeah, what happens if we make this an 8? If we minimize this when it wants to be maximized, then this has to be maximized when it wants to be minimized. So then this is a 1, this is a 2. So this has to add to 15, which makes it 8, 7, which does work, unfortunately. Let's just back up there then. That also seemed like it was on the right track, at least. Let's just look at some normal Sudoku, maybe. 6 along there is not helpful. 5 along there. Is there something I don't think there's anything I can do with the blues yet. I feel like that's a later step in the puzzle. Although maybe I'm just missing out on something. There's just a lot of options for like these are a little bit restricted, but like this could be 8 or 9, which is really, as long as once you get a couple of these big digits going in here. Well, let's look at this cell. This cell could be a 1, can't be a 2, 3, could be a 4, could be a 5, can't be a 6, could be a 7, could be an 8, but it can't be a 9. At least one of these 2 cells is a 9, because green only has 1 digit of wiggle room. So it could be... So this can't be 9 is what I was trying to say. What if this is 9? If this is 9, this is 9, this is 9, and this is 9, then this is already a 9. Puts a 9 over here, 9 right there. A 9 down here somewhere, and a 9 over here. Yeah, that doesn't quite work. This is a 5. Oh, maybe that's... Maybe that's something? If this is a 5, this must be a 9, which then reduces up here, which forces maximums all the way down here. And then this must be 2, but that doesn't break anything. And that solution works just as fine as every other solution. I thought I was onto something when I noticed that, or when I realized that that would minimize up here, but it does not seem to matter. 7's up there. This can't be 1, 2, could be 3, 4, can't be 5, 6, 7, could be 8, 9. That's not super helpful either. This is certainly tree. There's something obviously to do here, but so if this is an 8. Oh, that's a problem. Is that a problem? If this is an 8, this must be a 7. So these two have to add up to 10. But these must be maximized, which makes this 8, which makes this 2, which makes this 1. That works as well. For some reason I thought it would... I think it minimized a couple times on dark pink, but not overly so on light pink. Huh. Now, let me just look at that again. Does this break the puzzle somehow that I don't notice? Seven's put 7 up here somewhere, that's fine. Yeah, I don't think that's... I think it will be kind of a chain like that where, you know, some digit in a certain spot is going to force the little killers to break, but obviously knowing exactly where that is a problem. If this is a 1, this is a not. Whoops. This is a 9, 8, which makes this a 2, 1. This has to be maximized because of the 8. And this has to be 9. But that's the 5 situation, you know. Let's look. Okay, what are the options for this? A 1, 2, no. 3, 4, yes. 5, 6, 7, no. 8, 9. Yeah, these blue digits just seem so wide open that it's just... Oh, maybe this is how I need to think about it. Okay, so 32 plus 21 adds up to 53? Maybe that's not how I need to think about it. I was going to say this adds up to a minimum of 15 because there's 5 cells in a cage. Actually, it adds up to a minimum of 18. Oh no, it adds up, it can't even have a 3 in it. One of these is a 3. So it'd be 1, 2, 4, 6, 8. 1, 2, 4, 6, 8 is 21. Be 7 plus 6 plus 8. So this is a minimum of 21. But this could... it can't even be that minimum, because if this was 21, this would have to add up to 30. And that adds up to 30 maximum, and this would have to be another 1. Or maybe it could work. If this was exactly minimized, it could work, but I don't think so. Yeah, the minimum would be 15, 15, and then like something here. What can this digit even be? Can't be 1, 2, 3, 4, 5, 6, 7, 8, 9. It can't be a 9 because I would force both of those to be 8s. So that is a bit restricted. Oh, and it can't be an 8. There's just the 8, 9 pair up here. So this is a 4, 6. That is pretty restricted. Is there something that this does? If this is a 6, then these 4 digits add up to 15? Hmm. So where can 9 go up here? It can't be there or there or there. Yeah, anywhere that sees 2, so it can't be there either. It sees 2 digits on this line. It cannot be a 9 then. But that's still 5 options. That's not... well, I guess it can't be here because it's literally a 3 or a 4. 4 options. Not quite helpful. Okay. I keep thinking that there's something to do with this 189 up here and interacting with this 8-9 pair, but I can't quite see. Actually, that's something. Okay, that is something. So in this column, 8 and 9 are restricted to these 2 digits. I'll mark them as gray. Actually, let's just delete the coloring for a second. In this column, 8, 9 is restricted to those 2 digits. And in this column, 9 is restricted to these 2 digits as well. That's an X-wing. What that means is when we finish the puzzle, we'll either find that 9s are like this. Like if you imagine an X with kind of like this as being one of the arms of the X, but just like draw an X from along the diagonals. Either these both will be 9, or both of these will be 9. Because you can just see if I put a 9 here, that this can't be a 9, therefore this is the only other spot, right? And what that accomplishes is that it rules 9 out of every other spot in those rows. So the yellow spots can't be 9 anymore. If we try to put a 9 here, well, this column is fine, but then this one, we put a 3 here, but then we need a 9, and we now have 2 9s in the row. So we have an X-wing on 9s here. That's good. Okay, so that means these 2 digits can't be 9. None of these can be 9, although I already knew that. None of these can be 9. I don't know how helpful that is. It feels... which forces 9 into one of these 2 spots in this column. Because it can't be up here now, it can't be down here. It can't be here because of this 9, so it must be here or here. Maybe we're working our way up to... maximizing blue, or sorry, like minimizing blue or something is still too large? I'm not sure. What other digits must be in here? 6 and 2 are over here. 8 is down here. We can't quite force it onto blue. Oh, this can't be a 3, which I should have realized because I put 3s there. This digit, this 4 or 8, is up here on this line. Or in box 1 in column 3. Because it can't go anywhere else. It can't go anywhere along here. I don't know what that means, though. But it's something. Yeah, if this is a 4, then this is a 4. I don't know how that matters. If this is an 8, this is an 8, but that's easier to see just because 9, 8. Is there something we can... It keeps feeling like these two, since this is a pair, this is somehow going to be affected by that, but I don't see how. I was just thinking, if this is an 8, that puts 9 in both of these cells. So it puts an 8 here, which puts a 4 here, which pops the 4 back up here that we talked about. Puts a 4 here, a 3 here. Oh, that actually breaks the puzzle. No, it doesn't. Wait. This is a 4, this is a 4, this is a 3. I think I said that this... So this would be a 6. I think I said that wrong. Which would force this to be a 7. No, I think I just misspoke there. And then made a mistake. So this, if this is an 8, this is a 6, 7. So then this would be a 1. That is a little weird. If this is an 8, this is 9, 9. This is going to be 7, this is going to be 8. This is 1, this is 2. So this must be 8 to do the one cell, or one digit down in light green. We now have 16, 18, this must be 7. Okay, that's not actually a problem. Oh, and this is a 3 then, yeah. That's not actually a problem. Huh. Okay. Feels like I'm so close to figuring out what I need to do here. So this is a minimum of 19 now. This is a minimum of 21, which makes it a minimum of 44 in total, which isn't that low. What is it? So 2 is up here. If 2 was not in this cell, 2 would be here. Oh, you know, one thing I just noticed, 2 is in one of these cells. Oh, which actually places the 2 and the 3. Oh my gosh. Right? Yeah, that I should have noticed this a while ago. So 2 in this box, I think we've talked about it or I've thought about it. This can't be a 2. This must be a 2, which forces the 3 down here. So then this is a 4-6 pair, which forces this to be a 6, forces this to be a 4. That can't be that. Gosh, that has been there for a long time. I don't know. That's frustrating. Okay, so 7 must be there, which makes this a 7, which means this can't be a 7. Uh, but unfortunately, that doesn't quite touch enough of the lines. I guess what are these? This is 189. Oh, that is helpful. Oh, there's a 4 there, which makes this a 3. And this is a freebie now. This is a 6, which makes this a 7, which I literally just said it makes it a 7, which is going to resolve a little bit. Now we've finished light pink. We no longer have to worry about that. So now this adds up to 23, which means it's either 887 or 995. Which means that this is always a 9. Right? Okay, so if this is 887, then light green has to be maximized, and that's a 9. If this is 995, that 9 makes this an 8, which also means that needs to be maximized. Whoops, one too many. So this is always a 9, which removes 9 from those options. It felt like there was something to be done there in that box in that column, but I don't quite see it. 4 and 5 are along here. I don't see it. 9. Is there something going on with 9s here? I don't think so. We still have the X-Wing on 9s. But we can't really get any, not that I see. Okay, so this is 17, so one of these is 8, one of these is 9. And both of these, so these both are the same digit. So if they were 9s, we would have 9 right here. If these were 8s, we'd have 8s down here. We're so close. There's a 2 in one of these spots. What was the other one? 189. 2, oh, 7. Oh, 7 is also in these two corner spots. So this is a 1 or an 8. So we have a 2, 7 looking up here. So this is a 1 or 8, and this is 1, 4, 5, or 8. Ones are there. So 1 is in the middle. I don't know how helpful that is. We are at least slightly restricting dark blue a little bit. Maybe this cell is restricted. It can't be a 1. Where is... Oh, there's already a 1 in the box. I legitimately didn't see that. That's worrying. So 1, 2, 3. It could be a 4. Can't be a 5. Could be a 6. Can't be a 7. Could be an 8. Can't be a 9. Okay, if we maximize all of these, this is 17, 18, 27. That's way too big. Okay. What if we minimize these? Well, no, let's look at maximum again. Let's actually finish that thought. So this is 24, 25, 34, 34, 42. So no, that's not 10 digits of leeway. That's way too much leeway. Oh, this can't be an 8 because one of these is 8, one of these is 9, so this can't be an 8. See, 9 is over here somewhere. Two is down here. 7 is in one of these corners. What can this digit be? 1, 2, could be 3, 4, 5, 6, 7, 8, 9. Oh, that's actually not helpful at all. Okay. Kind of expected it to be a little bit more restricted than that. What about this cell? Could be 1. Sorry, can't be 1. Could be 2, 3, 5, 6, 7, 8. Okay, that's not helpful either. This one of these is a 2. So what's actually the minimum for these cells? I guess if we maximize these two cells, this would be 12, 15, 21. So the minimum for this is 24. Let me double check that. This is 1. No, this has an 8 in it. Yeah, I think 24. Which means this is 28. This means this needs to add to maximum of 25. Which means these need to add to a minimum of 20. So if this is a 2, this would have to be an 8 because it can't be a 9. But did I say 20? No, that's not right. This could be a 6 or more, so it would have to be an 8. Okay, I said A, and A was correct, but it was correct for the wrong reasons. Let's look at this column. This is 3, 4, 8, 9. This can't be a 9. This can't be an 8. Let's say 24, 28 means this has to add up to a maximum of 25, which means the rest of the cage, or sorry, the rest of the box must be a minimum of 20. So if this was a 3, this would be 15. This would have to be 5 or more. Can't be 5. This would have to be 6. Can't be 7, 8, or 9. So this has to add to a minimum of 20. This could be a 2. Yeah, this 8 here really, whoops, really allows a lot. Hmm. Yeah, if I rule the 8 out of here, basically, I force the 8 onto blue. What's the... What is... This is so... This is gonna be so high. What about minimums? 5, 9, 14? That's only 7 digits of leeway. If this is 9, and then... Oh, this can't be a 9. Um... Hmm. If this is 8, then this would be 4, 4, 16, 3, 2. Yeah, that works just fine. 8, 4, 5, 1, 9, 8, 9. 9, 5. That's fine. Because I said this was a 4. And that was a super long chain as well. Well, I thought I had made a break for the end here, but not quite. What's left in this row? 3, 5, 7, 9. This can't be a 5 or a 3. This can't be a 7. So this is 7, this is 9, this is 8, which is what we expected because it's 8, 8, 5, or 8, 8, 5. If this is 8, then this is the 8, 4, 3, 2 that we talked about. This is 9, this is 5, this is 9. This is 9. Oh! There we go. Okay, if this is 8. In order to make this math work, this must be 4, 3, 2. Now, where do we put 9 in this box? It must go here. Which makes this an 8. Which makes... Oh, I said... Which makes this a 9. And this an 8. Wait a minute. I could have sworn it broke the puzzle here. Makes this an 8. This a 7. How was it that it broke the puzzle? If maybe it was here. If this is 8, then this is forced to be 8, because these two can't be 8 anymore. That then makes this 4, 3, 2, which then puts a 9 here and forces an 8 here, which then breaks the line. Yeah, if we try to put an 8 here, this line is forced to be minimized, which offsets the 9 and then breaks the green line. So this must be 9, this must be 8. Whoops. Yeah, there we go. Okay. So we no longer need light green or pink. Okay. Let's change the dark blue. I do find that a little bit hard to read. Okay. That gave us some digits, but how much help did it give us? So this is a 4. This is the 9, so this is a 1. Okay, this is actually going to give us a lot. No, not 5, yeah. This is a 9 then, because of that 7. This 3... Whoops, put those in backwards. Yeah, that wouldn't... I don't think that would have mattered. This can't be an 8. Those can't be 8s. These can't be 4s, that's what the thing... And then, so this is an 8. So that can't be an 8. No. 8, that's a 1 then. Okay, let's start filling down here. This is a 4, 6, 9. Not a 9, not a 6. This is a 2, 3. I'm dumb. This is 2, 3, 6. This is 4, 8, 9. This is not 9. This is not 8. This is not 6. This is not 3. This is not 2. This is a 3. That's not 3. This is also not 5. Okay, along here is 1, 2, 4. This is a 1. This is 3, 5, 6. This is not a 5. That's all I can get from that. Okay, I think we have to deal with the lines now. So this at a minimum adds up to 14, so we have 7 digits of leeway here. That's a lot. What about here? If we do minimum, or if we do maximums, no, that's way too high. If we do minimums, this is 7, 8, 17, 21, 23, so that's 9 digits of leeway. That's even more. Okay, so what about this? These digits as a whole add up to 53. These, yeah, the blue and green as a whole add up to 53. We subtract off this 4. That's 49, which means yellow adds up to 41. We have 21, 26, 29. So these 3 add up to 12. Which means this couldn't be a 7. Let me check that math. So 90 minus, yep, no, 45 times 2 minus 21 minus 32, and we're going to add that 4 that we accidentally, or we didn't accidentally, that we subtracted off. That leaves 41, as I said, minus 8, minus 7, minus 5, minus 6, minus 3. Leaves 12, as I said, so this cannot be a 7, because if this is a 7, this is a minimum of 4 and 2. So this is a 2, this is a 7. Okay, if we make this an 8, this is 24, 25, this would have to add to 7, which actually works. That's annoying. Oh, this 2, we can do more with that. This is looking down here. So if we now subtract, so these two have to add up to 10? Yeah, so this must be 6, 4. This is 8, 5. This is 4, 2. This is 10, 12, so this must be 9. This must be 3. Great, now we just have to finish off the puzzle. This is a, whoopsies. That's the 6. This is not a 6. This is not a 2. This is the 9. This is a 3 or 5. Can't be a 5. This can't be a 4, so it's a 9. This can't be an 8 or a 9, so this must be 4. This is 5, 4. Oh, that's it. I was expecting more. There we go. I was stuck there in the middle for a really long time, but and I think it had to do with the, oh yeah, it had to do with the 2s over here. That was kind of a silly mistake, but that was definitely a tough puzzle. Got through it, luckily. So thank you for DJV for the fun little killer thermo Sudoku puzzle. Thermo Sudoku? I don't know, thermo Sudoku, whatever. Thank you for the puzzle. That was a lot of fun. I liked how easy it started out, and then just kind of kicked you in the teeth as you got going. Anyway, thank you guys for watching.